Hello, everybody. Welcome to that session about uncertainty metadata. We are the three co-chairs of the model benchmarking, the CMIP model benchmarking task team. That would be myself, Ranjini, who just switched on her camera as well, and then Forrest, who will give you a brief introduction on what the model benchmarking task team is doing and how we got to the point that we have this drop-in session. All right, hand over to you, Forrest.
Okay, thanks, Birgit. So we have a quick slide deck here that I'll run through. So in thinking about and trying to support this modeling multiverse out of WCRP, we have a state now where there's a variety of modeling activities and modeling projects that include CMIP, Cortex for downscaling, high resolution activities, new emulators and simulators from AI coming online. And this really represents a large collection of modeling activities that are going on within and around WCRP activities. Next slide. So given this broad swath of modeling, it's become even more important that we have some systematic model benchmarking and evaluation capabilities. So as these models are becoming more complex and as we're developing AI and machine learning models, we really need a way to comprehensively and systematically evaluate their performance with respect to observational reference data. And evaluation is sort of one of the terms that we use in describing this activity. Assessment is sort of a synonym of that. And then when we go to benchmarking, usually what we're doing is we're ranking the performance of individual models for individual metrics or for aggregates of those metrics to give us some sense of how the formulations within those models behaving relative to the other models with regard to the particular metrics and observational reference data that we're using. Next slide, please. So I kind of walked through this, the definition of model evaluation, this process of assigning simulations or assessing the simulations against observations to look at model fidelity. Next slide. Yeah, and then benchmarking is this process where model simulations are evaluated with observations and the models are somehow ranked or given to, intercompared with respect to their performance against various metrics. Next slide. So there are a variety of benchmarking and evaluation schemes, some of which we've described here. And this is from a paper that's currently in review, but that includes portrait plots that give us some relative z-score ranking of individual models for individual metrics or individual data sets, individual diagnostics. Variability and biases. We look at spatial patterns and spatial pattern correlations, overall budgets like carbon budgets and other energy, top of atmosphere energy, other budgets within the models, and statistical analyses. So if we often check to see if we're getting the distribution of various quantities correct in comparison with observations, and then a variety of other Earth system metrics that may be more like emergent properties that we may or may not have some clue from the real world, but we want to intercompare those properties amongst those models. Next slide. So for CMIP phase 7 phase, it's evolving rapidly. There has been a plan now to have an assessment fast track activity so that the critically important simulations needed for the IPCC 7th assessment report will be available. And so that's what's planned now. And then later activities for a broader swath of CMIP 7 simulations. Next slide. So as a part of CMIP for CMIP 7, the CMIP IPO has organized a variety of task teams. One of those task teams is the CMIP model benchmarking task team, and Birgit introduced the three of us who are co-leading this model benchmarking task team. Our objectives, of course, are to come up with ideas for how we bring evaluation tools into the CMIP process, into the CMIP project itself. We oversee the validation and testing and implementing a framework for the assessment fast track called the REF, this Rapid Evaluation Framework. And so we're going to talk a little bit about that to sort of set up the rest of the discussion today, and develop a vision for future model benchmarking tools and methods that would contribute to CMIP activities. Next slide. So as a part of this, we've collected online a list, a little database of various tools that are useful for analyzing or processing climate model output or climate data from observations. And at that URL, you will find a list and a collection of these tools. This is also open for people to contribute their own tools to this database. Next slide. This database also includes benchmarking and evaluation tools like ESM-Val tool and ILAM and PMP that you'll be hearing more about. And again, this is a database of open source tools that are available out there that have some standardized data that you can download and use to evaluate simulations from CMIP. Next slide. So the Rapid Evaluation Framework is this concept was developed as a community-owned evaluation framework that could be built upon, that would be compatible with existing community available packages and actually leverage their capabilities, integrate them into an application programming interface for executing diagnostics with various metrics. The goal here is to complete an end-to-end system in advance of the assessment fast track activity. So our long-term goal is to have this rapid evaluation framework online and assessing AR7 simulations. We're going to provide the ability to integrate these tools for CMIP publications and a CMIP workflow. So we're hoping that the IPCC authors will be able to leverage these evaluations and the summaries that are generated as a part of the rapid evaluation framework. We also expect to have wider community use beyond CMIP of the REF. And so we're thinking about how to institute some kind of body to carry on the work of the development and integration of the REF and prioritization of new diagnostics into the future. Next slide. So we envision the REF as not only a tool that people could download and use at a modeling center, but that would operate at the Earth System Grid Federation. So as data are published by modeling centers and undergo a QA/QC process, those data would then trigger the execution of the REF if they are data that are being analyzed as a part of these model intercomparisons and model data comparisons. And so new published data would kick off a process that would allocate storage and compute and generate a list of tasks and execute those tasks, leveraging various diagnostics and metrics that are available in the community packages, generate output that would then be published on the website at ESGF, so that data users would be able to look at the relative performance of some of these models and make decisions about which models to use for what kinds of investigations or downscaling activities or whatever, depending on the topic of interest of their own research. And this is something that hasn't been available in general before. The REF deployment would look something like this. Where we'd have a compute engine, and these are details like within the Earth System Grid Federation, where we have an event stream that would feed a compute engine that would allocate the storage space and compute, execute diagnostics out of ESM-Val tool, PMP, ILAM, and IOMB, and then generate these output data sets and web pages. Next slide. We're doing our best to treat uncertainties in the model, in the observational data. And so we have done some work to try to encode this for data sets that we have in OBS4MIPS, for which we have real uncertainties provided by the data providers. Next slide. So we want to thank everyone. The U.S. Department of Energy and ESA have put up funds to make this possible. The work's being done on multiple continents, bringing together folks from Climate Resource, Oak Ridge National Lab, DLR, the eScience Center in the Netherlands, Lawrence Livermore National Lab, with tools that include ESM Tool, ILAM, PMP, and CMIP, which you can read more about. Next slide. So you can find out more on benchmarking itself, on a preprint for a paper that we have in review on model benchmarking. That's sort of a retrospective discussion. That's shown on the left. On the right is a preprint for a GMD paper that describes the actual ref and the organization and how we surveyed the community and brought the information together to do the development that's currently ongoing. Next slide. Right, and so in October, we're planning an early release of the ref. It's already available for beta testing. But in October, we expect to have a version that's working well with CMIP 6 and CMIP 6 Plus data. And then at this CMIP 6, at the CMIP 2026, community workshop in Kyoto in March, we expect to have a full CMIP 7 operational version of the ref available to the community with the automated system running on ESGF and making those outputs available to the research community. Next slide. So thanks. This is the three of us plus Jared Lewis, who's the ref delivery team technical manager at Climate Resource in Australia. Thank you.
Thanks, Forrest. If you have any questions regarding what Forrest was telling you, or if you want to know more about the ref, for example, or something else that he presented, go to the Slido deck, please, and put your questions there, because we have a full schedule, and I hand over to Emma now, who will tell us a little more about the workshop that has happened just recently.
Thank you very much. So I will share. So hopefully that's showing my full screen.
Yes, it is.
Great, thank you. So I am reporting back on a meeting that happened this week. It was a predominantly UK meeting, but very much aimed to do some pre-thinking to share with the wider complete community. I'm Emma Williams. I work at the National Physical Laboratory, which is the United Kingdom's National Metrology Institute. Metrology being the measurement science, so the SI units, and uncertainty is of course a core topic. So we held a meeting earlier this week. You can see there a list of the participants. They were predominantly from the UK, but they came from various different institutes, and many of them had connections with the wider community. We were asking a question about identifying how we can store necessary information about observational uncertainties along with the observational data sets in a way that balances both simplicity and completeness and is practical for both data providers, those that are creating observational data, data translators, so those people who are taking raw observational data and preparing it in a way that suits modelers, and the data users, for example, the modeling community. So we held it this week partly to meet some urgent UK need around the UK ARIA forecasting tipping points program that's trying to define how it will document uncertainties for the instruments that it's having, that it's funding the development of, to assess tipping points in the Greenland ice sheet and North Atlantic subpolar gyre. and of course to support the requirements for the climate ref, which we were aware had happened, and we wanted to make sure those two activities were aligned. So we brought together the people you see on the right to have these discussions, and today we are ensuring that we have that feedback, because of course it's very important to us that this is an international activity. So I want to give a little bit of context. Now, I'm giving this context as a metrologist, measurement scientist, who is working in the field of satellite observations predominantly, some in situ too. So I'm coming from that perspective. And I think one of the things is to be aware of this, that there is actually almost a continuum from measurement to model. And there is a philosopher in the US called Bokelich, and she has this concept of model-laden data. So you have a measurement, but to interpret that measurement, you need models. Even something as simple as a thermometer, you have a model that converts a measured resistance in a wire, for example, into the thermometer's temperature, and potentially an additional model to compare the temperature of the thermometer to the temperature of the air that it is measuring, and then further models that might then be looking at things like handling diurnal cycles, or assessing what region that temperature is representative of. This is very much a diagram from an observational perspective. Other people on this call will be far more expert than me on the right hand side of this diagram, and all the different ways that you could split that up and perhaps create data laden models in the same way that you may have model laden data. My main point here is that there is a continuum. There's not a simple thing that this is an observation, this is a model, and some of the issues in uncertainty come from making the decision as to whose responsibility it is to assess uncertainties at those interfaces. I do want to make a really strong point. I am a metrologist. We have the International Vocabulary of Measurement of Metrology and the Guide to the Expression of Uncertainty in Measurement, and error is not the same thing as uncertainty. So just to make sure everyone's on the same side of this, you have some sort of true value, it's conceptual, it's unknown, and you have your measured value, which differs from the true value in some way. The difference between those two is the measurement error. And it is unknown, but has a number associated with it, which we just simply don't know because we don't know where the true value is. So although we don't know what the true value is, we can say something about the distribution around the measured value in which the true value is likely to lie. And that's what we describe by an uncertainty. So the uncertainty is the standard deviation of the distribution around the measured value in which the true value is expected to lie. And that's why the two things are not the same. And it's why uncertainties can't be systematic and random. It's the error that is systematic or random. I'll come on to that in a bit more detail in a moment. And why there is a difference between errors which can never have numbers associated with them, because if you knew the number associated with the error, you would correct for it. It's the uncertainty that you put a number on. So why is systematic and random not enough? And there's really two reasons for this. One is that, well, fundamentally, it's about the fact that in environmental observations, as opposed to in laboratories, we tend to take lots and lots of measurements at different locations and different times, and we have enormous data sets that combine them. And you can have things that are systematic in some ways and random in other ways. So, for example, you can use these, people use these terms random and systematic to describe the origin. You know, is it coming from a stochastic process? Is it coming from a quantum process? Is it coming from some process that has some statistical variety? That's more random. Is it coming from something systematic? So in principle, if only we knew more, we could correct for it. Now, often it's actually something in between. It might be stochastic in origin, but we're using it but we're now using it in the calibration of an instrument, and then we use that instrument for a long time. So we sometimes have something in between. We can talk about the error correlation structure, as in, is the error in one measurement at one location and time the same or different from the error at a different location and time? And it might be independent, or it might be common, or it might be structured. And then within the metrology world, we talk about type A methods for assessing uncertainty, which is where you take a standard deviation of a repeat reading, on type B methods, which are other methods. So you can have any combination of these. You can assess a stochastic origin uncertainty using a type B method, and it could have a structured correlation structure because of how it's used. Even more importantly, it may be different in different dimensions. So some source of uncertainty might be random from one instrument to another instrument in a instrument array, but it might be systematic over time for one instrument alone, or vice versa. So we have to move beyond that. And there are other ways that climate observational data and their uncertainties are unique. We have complex processing chains, often involving different communities, particularly in the satellite world. You'll have the people who make the instruments, produce level 1 data, completely different communities that take that and produce climate data records of essential climate variables, different people again who might then do gap filling and regridding. You have to pass information between them. We have large volume multi-dimensional data sets with all these different dimensions. There are aspects to do with sampling. Some of that's to do with how the satellite physically goes over in a particular way. Some of them are uncontrollable. For example, we miss certain measurements because there's clouds. We have diverse user needs and an evolving approach to uncertainty. So historical and modern data sets differ significantly in how uncertainties have been assessed in the past and what sort of level we need now. And it's for this reason that we realize we need to move beyond the existing climate and forecast metadata conventions, the CF conventions, which have simply one concept for what they call as the name standard error. And I've already explained why it's actually a standard uncertainty. In their description, they call it a standard uncertainty. So we need to think about that terminology, but more importantly, one concept, one value is not enough. We need to be able to handle these correlations, for example. So in the observational world, lots of work has gone on with lots of different communities, in situ data, satellite data, active sensors, passive sensors, data derived from satellites through processing. And we now have what we call the QA4EO 5 steps to an uncertainty analysis. That's the quality assurance framework for Earth observation, 5 steps, which go through a process to assess uncertainties. This is within an iteration. Because often when you do it first time, you then need to go back. But equally, sometimes you also need to do this separately at each level of the processing chain. So just very quickly going through them, it's so important to define your measure and, particularly when you're going to compare with models, because what in this case, Sentinel-6 calls global mean sea level may not be what a modeler would call a genuine global mean sea level. Sentinel-6 is not seeing the entire globe. It misses the poles, for example. It's taking an average over a footprint, how it's handling tides, how it's handling these things. There may be differences, and this is just one example. It's so important to define what does your measured value actually represent. We have a step to assess the traceability with a diagram. This comes out of the Fiducio project, and what you can see is you're trying to explain where everything comes from and what the sources of uncertainty are. Now that provides potentially enormous amounts of information about uncertainty. And then you need to think about how for every source of uncertainty that's on a diagram like that, what is its correlation structure in each dimension that matters, what information do you know about it? So you fill that out in an effects table, and you can do that in reports like the table on the right, and we're now looking at the metadata standard of how do you store that sort of information. Of course, you might think about how much information different users want to know. Then we might propagate uncertainty through a process of calibration steps or data processing steps, and we can follow the guide to the expression of uncertainty and measurement, which is the standard approach, and that allows for both the law of propagation of uncertainties, which is the square root of the sum of the squares, roughly, and the Monte Carlo methods, which is like an ensemble approach. NPL has been developing some toolkits to simplify uncertainty propagation for a wide range of satellite sensors and in situ data sets that can implement both approaches and can handle these detailed information about individual sources of uncertainty. And then we might be looking at this question of how we store and disseminate that information. So this is where the metadata comes in. So for people who are other observational scientists working at the same level, we need what in Fiducio we called the full FCDR, the full data set, where we really store each source of uncertainty and everything we know about that source of uncertainty, so that future scientists can check our work, can understand our work. Anybody who really wants to open the black box can get all the detail that they wish to have from it, and that it can be improved in the future. In addition to that, we need to be able to simplify this and provide summary information at a level that is sufficiently complex, but not overly complex for users who don't want to understand all that detail. So in the full data set, we might say we have an uncertainty due to temperature, and it has this error correlation structure in this dimension, this error correlation structure in that dimension. Then we have an uncertainty due to noise, and it has these different ones. In the easy FCDR, we want the simplest set of data, and we believe that that is often 3 pieces of information. What is the component of uncertainty that is associated with effects that are common spatially and temporally? What is the component of uncertainty that's to do with things that are independent, have an independent error spectrally and spatially, and which bit is to do with effects that are somewhere in between, and what is the scale on that? So what we had is we had a meeting at Reading University with the people we've mentioned before to discuss how we might practically do this. And we had within this meeting 3 breakout rooms, one that was looking at developing generic flexible guidelines that can be used long-term for storing uncertainty metadata at any complexity that is appropriate, along with the tools to process that. One on the development of specific guidelines for the climate ref exercise that we've just heard about, and one on broader needs and requirements of the observational model interface. So that was more looking for making recommendations to the communities. So breakout room 1 was building a generic uncertainty metadata convention activity. So this was actually building on the NPL proposal that had come from the COMET toolkit. So this toolkit that can propagate uncertainties. So the idea here is to think a bit like image processing that people do. People can do quite sophisticated image processing, often by having tools that do the image processing and then making choices. So here the same sort of thought was that we would provide some software tools that can take arbitrarily complex uncertainty information and propagate them through to users. But equally, you could use the same generic uncertainty metadata conventions to store much more simplified summary information. So you can see there the current one, but as a result of the discussion in the meeting on Tuesday, we are updating this particularly to make it more CF compliant. We had representatives from the CF conventions in the meeting. So we're trying to be open and flexible, but actually in a way that it can also be developed towards more specific frameworks. So the next steps for that activity would be to refine the current proposal and do some tests on some selected data sets. We had some within the group that we were going to use, but in addition, if anybody feels strongly that they'd like to be in that very early involvement in this, we welcome input from the committees to suggest which data set should be in that early thing. Once we've iterated it over the next few months with a few data sets, then in, let's say, Q1 2026, we will launch an open call for beta testers. So this will be public, anyone will be allowed to be part of this, particularly looking at those people who work at the observation model interface, who are preparing observational data for model comparisons to try and develop, to test out the generic metadata conventions and see how they work. And then from that, we want to produce some good practice guidelines, which we will submit as a formal proposal to the CF conventions towards the end of 26, I'm guessing. And so we welcome involvement from all of the communities. We're going to raise awareness as we do this. We'll be very public about it. And we want to keep open the option that we may lead to ISO standardization if that's felt to be appropriate. So that was breakout 1, and they were looking long term, but we have this more urgent need for the climate ref. And we wanted to build on what had already been proposed. So the climate ref community that we've discussed earlier today had some meetings back in earlier part of this year, and they had an initial proposal which you can see at the links there. They have accepted that the term standard error is used in existing data sets. So this is now described as legacy with an alternative term, standard uncertainty, which mean exactly the same thing. There is an option for classifying the error correlation using the independent, structured, and common terms. We've intentionally not gone down random systematic, partly for the reasons I told you earlier in this call, and partly because we want to make people think, so it's not terms that they think they understand. We have also, because, so in the long term, people would like to have the uncertainty data in the same file, but in the short term, we are going to be doing this compromise by using global attributes of has orgs data equals true, then you provide IDs to the other files. So the next steps for that is to get that out. It has actually already had some updates to the online version of that. And then we're going to use the climate ref example as one of the examples of testing the generic framework. And again, we're going to involve the communities. We're going to make a recommendation to WeGork about the to get them involved in this review and a process. So breakout room 3 looked at the needs and recommendations from that interface between observations and models. So we looked at some of the reasons why modelers want uncertainty information along with the observational data about not overfitting as they constrain models. We had this quite a long discussion about the value of how you think about how are you going to get to the generic output statistics. So some of those things that we heard in the previous presentation of what types of things get compared and how do you propagate uncertainties from a per datum information, which all of these processes are encouraging, into something broader. But fundamentally, we realize that we really do need a lot more collaboration, and we need to have some really good examples that demonstrate the value of uncertainty information, that show you how to use it, and the modelers were asking observational people to be more consistent in how they describe uncertainties in providing interoperability and uncertainty information in the same file as the variable. That kept coming up, as long with tools for regridding and considering these output statistics. So this is a summary of the formal recommendations, which perhaps it may make sense for me to leave on the screen as we go into some of the discussion. So the formal recommendations that came out of this meeting, we recommend to WCRP and CEOS to increase the strategies for forums and the resources for collaboration. This is fundamentally the thing that we really do need observational experts and modelers to be working closely together in discussion, but that requires funding, that requires people to organize the meetings. So obviously this is a big part of that. We're making some specific recommendations to WeGork to consider setting up a task team to review and devise means of combining observations and uncertainty. So actually getting into the technical detail of this, setting up a joint task team with CEOS Climate to look at how we can get some examples where you can show not only how to do it, but that it has made a difference, that we've considered uncertainties as well. And we are calling on the observational communities, whether that's CEOS or WMO, GCOS, the observational programs, to promote consistency of the naming and meaning of uncertainty information. There's been a lot of work in those communities, but that work is still, some people then present things in slightly different ways. So there needs to be a lot more work within the observational communities. We're telling OBS for MIPS that there is a scientific preference for having it in a single file, but we appreciate that the current tools make that difficult. So we need a sort of discussion, a working group to try and resolve those issues. We recommend to the CEOS working group on capacity development and climate to get better routes for the development of uncertainty tools and helpful ways of propagating to these final things. So yeah, again, we're recommending the development of the tools, and we want people to provide recipes and methods to help. So I realize I've gone ever so slightly over, so I will stop now in speaking, but maybe leave that up for a few moments.
Thanks, Emma. That's okay. That's those few minutes, I think. That was very interesting. So we have now, so if you have any questions regarding what Emma has presented, please put them on your Slido, in the Slido that Bryony had mentioned, where you can put all your questions. But for now, we will go and hear very brief statements from different organizations. And so I would think we should start with WeGorg. Who would that be that presents for WeGorg or says something for WeGorg? Doug, is that you? Okay, maybe we don't start with WeGorg, but we start with GCOS. Who would that be? Do you know that you talk?
Me.
Peter!
That would be me, Fergus. Sorry, you get me.
That's brilliant. Welcome.
Welcome. Really interesting to see the work on the NetCDF standards, and that's of direct interest to both the GCOS reference upper air network and the GCOS surface reference network, representatives of whom are on here. I can tell you that we have been using NetCDF, for example, for GRUAN, and we have made up uncertainty language in the NetCDF files because they're not in the CF convention, and I think it would be enormously beneficial to have those kind of standard conventions, but we need to make sure they work across the piece for all the different types of observation, which brings me perhaps to my second point, which is that this doesn't necessarily help bridge the divide between the modeling community and the observations community, where the observations community know all the nuance, that there are really high quality observations, there are pretty bog standard observations, and there are really poor observations, and the modeling community goes, it's an observation, it's the truth. And I think we need to work a little bit perhaps harder on those aspects, and those particularly taken by Forrest's take, the statement, and it might have just been a misstatement along the lines that OBS4MIP is the truth to compare the model to, and how often have we slipped up on that? Think back to the early 1990s and the furore over troposphere isn't warming as fast as the surface, and oops, that's because the observations were wrong, even though the observations had an uncertainty estimate associated with them. So I would urge a broader thing with use multiple data sets where they exist, and that is a limitation, a fundamental limitation of OBS4MIPs, because it's only the groups that could be bothered to upload to it, which is, or for most ECVs, a subset of the groups that could have uploaded to it. And yes, the risk of banjaxing, more often than not, when we've gone, there's the model observation discrepancy. Once the community's finally got down to the bottom of it, they've gone, oops, our observational understanding was wrong, not oops, the models were fundamentally flawed. And I do think that there's some great care and attention there, and it's about nomenclature, it's about education. And yeah, the last one, how are the observation community, how are the model community really grappling with and understanding this hierarchy of observational capabilities? Are they really making use of reference network measurements? Are they really understanding the difference, particularly on the in situ side, but even on the satellite side? Not all observations are equal. And how do we ensure that that is properly communicated? And it's partly about enabling it in the files, but it's partly about education. I think I'll leave my remarks there. As I said, there are representatives from both GSRN and GRUAN on the call, and you might wish to invite them if there's time to make their specific observations from their network perspectives.
Thanks, Peter. And yes, please, if you have any comments, please put them on the Slido or any questions so that we can actually get back to them later. I saw that the first question is already there, so please don't be shy, put them on there. I think Douglas is not on the call anymore, so I would now invite the representative of CEOS to talk, whoever that would be.
So if you're a member of one of the CEOS working groups, we know that we've got some that have registered. Do feel free to put your video on and unmute.
If you want to comment on things here. Doesn't seem the case, then, well, Peter, you were the only one talking. That's great. And so with that, I would open the floor for questions to anything or everything, comments. We have the Slido where we have we have one question so far. If you have any comments or questions, please put them on there. And I guess we go with that question.
Birgit, before we do,
Yeah.
Simon, are you putting maybe a CEOS or an ESA hat on, or an OBS hat on? You've got so many.
Well, I suppose formally for OBS, but it's probably more biased towards the climate change initiative and what we've been doing over the last 13, 14 years. I mean, first of all, thanks for taking the effort to define this standard. I think that's been something which has been really missing for a long time, and something that we, have for a long time felt is needed, because we see, amongst the satellite community, very different ways of communicating uncertainty, and perhaps also some different ways of understanding it, which can lead to an awful lot of confusion. And I think by doing what you've done and what this workshop has come out with, I think is a brilliant step forward in helping us to sort of improve all this confusion. So, I think it would be fantastic to have this sort of common understanding and this common nomenclature and vocabulary that you've defined, and a common way of reporting the uncertainty in the observational products. And also this sort of recommendation that a sort of easy version is to report the three different components of the uncertainty, in sort of random correlated and locally correlated, uncorrelated, correlated, and locally correlated. So I think that's fantastic. For OBS for MIPS, I think it's probably too late to adopt it for our current revision of the standard, which is sort of in its final, sort of being finalized right now and within the next sort of week or two. But I think we would be very interested to talk to you and sort of see how we can work this into the standard as quickly as possible, and both to sort of take advantage of it, and also to try and support the adoption as well.
Thanks, Simon. Yeah.
Can I just
yes, absolutely
respond a little bit to that? Because I think there's two communication pieces needed. First of all, we have to do this exercise of trying it out on real data to see what any confusions are and sort those. But I think we then have to work with the observational community to make sure everybody knows how to prepare data in the right format to be presented like this. So there is a big piece, and that's where CEOS and WMO and GCOS come in. And then there is this second one, which is to help people who are doing this model observation interface, OBS for MIPS, WeGOG, the CMIP activities, all of these together to look at how we can use that information. So I think there's going to be an awful lot of communication needed to get anywhere in both communities and in both directions. And it takes time, but a lot of the observational community has done some pre-work. getting it into the right format is also going to take time.
Thanks, Emma. Is there, like, Dora, do you want to have a little chat about VGORG, maybe, just very briefly? If not, that's okay. We can go to the questions.
I think I'm slightly biased because I was also there with my ref hat on. So obviously I'm kind of all for any further development. So I was hoping maybe someone else from VGORG would be here, as Emma was also leading the workshop. So the two of us are slightly biased in this topic.
All right, that's okay. Thanks, though. And with that, if there is any, like, is there still anybody from VGORG? Probably not. Otherwise, they would have probably already raised their hand or opened their mic. Okay, so I think we just go to the first question that we have here. That was raised. I just read the question and then whoever feels like who want to answer, probably Emma, I guess, or maybe we as the ref people. Have you thought about uncertainty in info beyond stats indicators, like a flag for which outputs are highly dependent on input data or diagnostics in nature?
Yeah, I don't know if the person who wrote that wants to add any
Yes.
detail. I can have a go at starting to answer, but if you're online, the person who answers, do put your camera on or add detail. So I think one of the things that came out of the discussion is that in the observational communities, we might not always know what information people, or like what steps people are doing to do the comparison. And there are lots of different types of comparisons that can be done. What we are looking at here is the uncertainty of the observations themselves, but that is only one part of the uncertainty or the process of doing a comparison, because how do you go from those to uncertainties in summary statistics or uncertainties in so on? And maybe this question is also about the fact that given you have these model latent data, you're actually using model outputs often in processing data. I see there's a hand up. Is that to add clarity to the question?
You
Yeah,
muted.
so
Okay. Yeah, there you go.
Try to do that. So I was thinking about certain kinds of outputs in particular that might interest people doing impact studies who aren't familiar with what really goes into the modeling. So you have things in the land surface outputs that are highly dependent on the input data sets that are specified. And another example, diagnostic in nature, I mean, sort of like a lot of the boundary layer things that they might be tempted to grab some of those near surface variables for different impact assessments, and they're really estimates in a way. So thinking of users who are really lack familiarity to let them know what something about the level of certainty that the modeling center person, if you were to ask them, would have about it, maybe in a more qualitative sense. That's why it's more of like a flag or something.
And maybe this is the type of technical thing that needs to be thought through at this interface. These people who perhaps these what I call translators, I don't know if there's a better word, but observational people know about observations, and there may be modeling people that know about the model, and then but there is this job in the middle to interpret what comparisons are meaningful, what comparisons are going around in a nice little loop because you've actually already used the data in the model, or you've already used the model data in the observation, and to sort of flag some of that. Yeah, there probably do need to be various flags to warn people of what comparisons you can and can't do with this data. But it would need people in that interface to define what those would be. What I understand is the uncertainties in the observations themselves, and that's what we were focusing on at this time.
Yeah, those translators, they will be like very, very important. Thanks, Naomi, for the question, and thanks for the answer, Emma. We have Thomas, you had a question or a comment. Do you want to open your mic?
Yes, so good afternoon. Not a question, just my full support. I have been looking at this UNC metadata convention and really think it strikes the right balance between completeness and simplicity. And I'm very glad that it is associated with a toolkit, so with software, so that we can have processing of uncertainties. And I'm referring to the COMET toolkit. There has been many attempts in the past to have uncertainties into NetCDF-CF, and they failed or they stalled. And I really hope that UNC will make the full way through. That was it. Thank you.
Perfect. Thanks for the comment. Yeah, it's great. It's great that it actually, kind of like that the whole discussion that we're having here is filling a need, right? I feel this is really important that we are talking about this now, and we got to the point because we are doing a lot of stuff in the observational side, but the modeling side, and then we are getting together. So this is great. We have another question. About the ref. Do you want to open your mic, as the purpose seems to be fast and rapid? That was Li Jing. Do you want to ask the question directly? I can read it. That's okay. So there was a question raised to the ref, which is encouraging. Oh, there you are. Okay.
Okay.
Yeah.
So I'm trying. So my question about ref is actually, so it's highlight the support to IPCC process. But I'm worried about that because ref is more rapid and fast. So how to balance the rapid efforts with the comprehensive effort that needed in IPCC process. So any plans or ideas from ref
Yeah.
people? Thanks.
Yeah, thanks for the question. I don't know, Forrest, do you want to answer, or should I? I'm chairing, so you answer.
Yeah, sure. I'm happy to answer. So we've thought quite a bit about this, and the initial work to produce the CMIP 7 assessment fast track version of the ref was aimed at trying to develop that whole end-to-end workflow. And so we had a small number of, on the order of 5 or 6 diagnostics per Earth system realm that we selected with input from the community. And we described this in that preprint that we cited earlier. And we would implement that system first. And then following on to that, we're working now to establish a body, kind of a panel that would help prioritize new diagnostics and make the system more comprehensive into the future. And so we're really looking for continued community input on, selection of who would participate in that panel. We also actually talked about this earlier today with the chairs of the CMIP panel, and talked about having an annual meeting, for instance, where people would come and show what they're doing with the ref, and then there would be some process about trying to integrate that for CMIP purposes or for community purposes, as the ref itself is totally open source and can be used for however people wish to use it.
Thanks, Forrest. Did that answer your question, Li Jing?
Yes, more or less. So let's keep in contact in the future.
Okay.
So
yes, absolutely.
So we can work on that. So but maybe I take this opportunity to ask another quick one.
Okay.
For the for the uncertainty group. So because I'm personally working on ocean, so the conversation just happened is more about the atmospheric and satellite community. So the ocean community is also working on the uncertainty quantification. So I'm trying to understand how to correspond our uncertainty quantification with your language. So if possible, we can also have a contact with each other so we can collaborate. By the way, I'm also in GCOS with Peter Schoen and Berlin, so we can have a contact in the future. Yeah.
Yes, I'll comment on this. So the ocean community is also is developing standards. I think there is more variety of both measurement methods and approaches, and so there are these bigger efforts towards the standardization. If we talk about physical measurements in the ocean, they can pretty much, they could in principle follow a similar approach to what we've talked about with the satellite data. With chemical measurements, I think there is a lot in common. And as I say, I work at the National Measurement Institute of the UK. As part of that, I am connected to the Metrology Institutes in other countries in the world, but particularly in Europe. And I have colleagues at PTB in Germany and LNE in France who are very engaged in uncertainties and traceability for ocean chemistry measurements. And I have some collaborations and links with them to look at how we can bring some of the similar approaches into the ocean chemistry measurements as well. But that's a different process. And there are some fundamental questions to do with what the measurand is. So in many ways, you can go through the same 5 steps, but the question about what is the measurand in ocean chemistry perhaps has more detail to be thought through in terms of what is the actual reference for the measurement and so on. So there is work on there, and I'm always looking to meet new people and connect. So I probably will send you an email, Li Jing, and actually try and make that connection.
Yes, thanks.
Thanks, Emma. So we are right sharp at past, but we have one more question, and I would like to give Belen the chance to ask it. And so Belen, if you are still here, then please go ahead.
I hope you can hear me. I don't know if you can see me.
Yes, I can hear you, but I see only black, but that's okay.
Yeah, there was some problem. I did get an error message. Sorry for that. And thanks very much. Personally, I really loved all the presentations, and in particular the one from Emma. And so I mean, I work for GCOS Secretariat, so I'm not an expert in this topic at all, but very curious about it. And I work with Li Jing because I support the ocean panel, so I know I can say that there is a lot of interest and appetite within the ocean panel about this well, about making progress, I guess, in uncertainty and how to describe it, etc., etc. So my question was more practical. I think we definitely want to engage, and so is this going to be, do we need, from GCOS perspective, and since we have also our work plan, etc., do we need to plan for this? When will you ask for our engagement? What are you thinking of in practice? Is this more putting people together in a workshop, or would it suffice with emails? Or I was curious to understand what you have in mind. Yeah.
I think we're still working that out. I think one of the things is to connect with all of the different committees. So actually working with GCOS, working with the WMO expert team on measurement uncertainties, working with CEOS, so on the observation side, and then with WEGOC and OBS4MIPS and CF standards. So all these different communities we're connecting with, and we may well have missed some. So I noticed that there's a poll that I assume Brani's put up in the Slido. What next steps would you like to be taken? If you think there's communities we really must engage with, please also add those to that question. what I think we do practically is we need to finalize this. So we've come a long way. We had a proposal. We had a really deep discussion on it on Tuesday, but that was with and that was with people who had a lot of experience, but they were all in the UK, and they were obviously it was the people who were available. So what we want to do is iterate that based on that conversation. And if you, particularly you as GCOS says, really you need very early on to try it on an ocean product, then let's add that to the list. I'd like to get that sort of thing coming more from organizations like GCOS than to come from, at this stage, an open call. When we've tried it, but if GCOS, if you would like us to try certain things, we'll try certain things. Then once we've iterated that over the next few months, I think early in 2026, we will do an open call, and then we will be welcoming all the organizations to be sharing that with their communities, to try and get as many people as possible to be aware of this. We'll hold some online meetings. We'll do videos on YouTube, or whatever it takes to get the message out and to get people to try things out. I noticed your comment, Peter. I'll make a note to be in touch with you about Gruan. And I agree with you. And actually, some of the work that's recently happened in Gruan would make it a very nice case study. Yeah, so I think we get the right communities together. We have to publicize it, and so the help of all the people who are representing communities in getting this publicized, so that we can, and we will be holding, asking people to try it out, sending out questionnaires, trying to gather information from people from all communities and all continents, to try and get that discussion going. Yeah, definitely.
Perfect. Thank you,
Thanks.
Emma. Was a good question, Berlin, and it really nicely leads me to thank you all again for showing up, for your interest, for participation. And I really want to stress out again, if you have any suggestions or any comments or any ideas on how to proceed that, the Slido is still open, the poll, you can add your thoughts there. And yeah, thanks for participating. I guess we will be in touch, and I wish you a very nice rest of your day.